we're going to go over how to find the horizontal asymptote for a rational function. So remember, the horizontal asymptote is a horizontal dotted line. So horizontal is in this direction here. And then to write the equation of that horizontal line, it's always y equals some number. So we need to figure out how to find that number. And it has some directions here. To determine the asymptote, we need the degree of the polynomial in the numerator and the denominator to be the same. If they are not already the same, we will use a zero placeholder to create equal degrees so we can find the asymptote. When the degrees are the same, the asymptote is at y equals the leading coefficient in the numerator divided by the leading coefficient in the denominator. So this right here is almost kind of like our formula for finding these. So let's get started with this first example. So the first thing we need to do is determine what is the degree of the polynomials in both the numerator and denominator. And remember, the degree of a polynomial is the highest exponent on a variable. So for this first one, the highest exponent in the numerator is 2. And then in the denominator, the highest exponent on a variable is also 2. So in this case, they both have the same degree. And so we can find the asymptote right away by just pulling the leading coefficients. In the numerator, the leading coefficient is 2. So remember, the leading coefficient is the coefficient of the term that has the highest exponent. So it's the 2, and it's just the coefficient. It's not the variable. And in the denominator, it is 4. So our horizontal asymptote is going to be at y equals 2 over 4. Or we can, of course, simplify that to y equals 1/2. All right, let's do this next one together as well. So I have f of x equals x minus 5 divided by x squared plus 3x minus 12. In the numerator, we have x minus 5. We can think of this x as being x to the first power. So the degree in the numerator is 1. In the denominator, we have an x squared. That's the highest power of x. So that is our degree. So here's a case where the degrees are not equal. It has a larger exponent on the bottom than it does on the top. So if we want to make these the same, I can't just get rid of x squared, but what I can do is I can add a 0x squared on top. Because technically 0 times anything is just 0. So I'm actually just adding 0, which doesn't do anything. But now if we have 0x squared, we have the same degree in the numerator and denominator. And so therefore we can pull the leading coefficients. In the numerator, the leading coefficient is 0. And in the denominator, the leading coefficient is 1. Remember, there's an understood 1 in front of a variable as well. So this one has an asymptote at y equals 0 over 1. Really, that's just y equals 0. And there's the horizontal asymptote. There's actually one more case that you might potentially see. And it's not right here, but I found a problem below that will have this special case. So let's look at a problem like this. I know it's x-intercept, so if you don't want to take notes right here, that's okay. Just watch what I do. The degree of the numerator for this one is 2. That's the highest power on x. And the degree for the denominator is 1. So I do not have equal degrees. I can even write that one there. But I need to get equal degrees. So we want the bottom to also have an x squared. So we will just put a 0x squared in front. And now they have equal degrees. So we can find the leading coefficient by, find the horizontal asymptote by pulling the leading coefficients. So up top, it's going to have a leading coefficient of 1. And in the denominator, it's a leading coefficient of 0. So we get an asymptote at y equals 1 over 0. But we have a problem. This is undefined. If ever you have this issue, that means that there is no horizontal asymptote because that value is undefined. We cannot divide by 0. It actually will show up as another type of asymptote, but that's beyond what we're going to do together in this class.